All right, in this video, we're going to be talking about section 2.2, where we're going to continue our conversation of slope and now tie it into some more information. So for this warm-up, I would like you to graph each of these lines that are described. In each of them, you're given a point that the line will pass through and a slope that the line has, so the rate of change. Okay, so go ahead and pause the video and go ahead and graph these. Let's see, I'm going to switch over to another window just so I can kind of graph each of them individually. So here's part A. Part A says we have the point 3, -4. So 1, 2, 3, 1, 2, 3, 4. So there's 3, -4. And then my slope is 2/3. Pay attention to the positive and the negative. So this is a positive 2/3. So my graph should be going up 2 and over 3. I would like to point out something that we can keep going up 2 and over 3, but since this line goes in both directions, we could also go -2, down 2, and over -3, 1, 2, 3. And that still, you'll notice, has us lined up. So 2/3 either is a positive 2 and a positive 3, or you could go -2 and -3. So down 2 over 3. Down 2 over 3 more. So if you're running out of room going one direction, you can go the other direction. And then the double check that you really ought to start doing until you become an expert at this, and even so, still good to keep checking, is the slope is positive. It's a slope of positive 2/3, which means it should be going up to the right, and it is. All right, the next one, we've got -4, 0. So -4, 1, 2, 3, 4, and 0. So there's that point. Its slope is -1/4. So I'm going to do a vertical change of 1 and a horizontal of 1, 2, 3, 4. So down 1 and then +4. Down 1, 1, 2, 3, 4. I could have also, back to our other discussion, I could have gone up 1 and then -4. 1, 2, 3, 4. Notice I'm still on the same line. Double check. Slope is negative. It should be going down. My slope is going down. All right, part C. -1, +3. Slope of -3. So having a slope of -3 means we're having a slope of down 3 and over 1, right? A whole number can be written as a fraction. So I need a vertical and a horizontal change. So I'm going to go from that point down 3 and then over 1, down 3, over 1. I could go up 3, 1, 2, 3, and over -1. Either way, I get points on the same line. And then this last one here, part D, 0, 2 is here. Up 1 over 2, up 1 over 2, or down 1, -2, down 1, -2. Either way, my slope should be positive, and it is. I'm going up. Everything looks good. All right, I think there's 3 more to do. All right. Slope actually is 0, 4. That's this point here. And a slope of -3/8. So down 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. And so going any further would be way over here. I could go up 3, 2, 3, 4, 5, 6, 7, 8. Still pretty far out there. It's kind of hard to draw a straight line when they're this far apart. I highly encourage you to use a straight edge while doing your graphs. Part F here is 3, -2, and a slope of 0. So this is where we got to remember what a slope of 0 means. It means I go up nothing and over, up nothing and over. That is a horizontal line. So a slope of 0 equates to a horizontal line. And then the next one, we have a point at 1, 1 and a slope that's undefined, which is code telling us that is a vertical line going through that point. Okay. Let me jump back to this screen. Okay, so warm up was graph those lines that include those points and those slopes. So we have done that. All right, let's scroll down. The y-intercept. The y-intercept is something that is, its name is very descriptive. The y-intercept is a point where your graph crosses the y-axis. Okay, so it's the point where the graph crosses the y-axis. So let's go back actually to this last screen we were on. You can see that in all of these pictures except for one, and we'll talk about why one doesn't in a second, they all cross the y-axis someplace. So let's see here, let's circle it. So here we have a y-intercept of 1, 2, 3, 4, 5, 6, 0, negative 6. Here we have a y-intercept of 0, negative 1. Here we have one of 0, 2. Here we have 0, 0. This one has a y-intercept of 1, 2, 3, 4, 0. Nope, that's a lie. 0, 4. This one, of course, is down here at 2, negative 2. And this one doesn't have a y-intercept. So y-intercept is just where the line intercepts the y-axis. All right, so let's go back here. All right, example 1, graph by making a table of values. Use the graph to identify the slope and the y-intercept. All right, so we've got a little bit of work cut out for ourselves here. Let's go ahead and get started. I'll make a organized chart over here, I guess. I'll do part A, y equals 3x minus 5. You can pick any value of x that you want, but I think I'm going to pick values that are both small and easy to do math with. So I'm going to pick values like, I don't know, I'll start with negative 1 and then do 0 and 1, because that gives us a nice look at the center of our graph. I plug in negative 1. I'm going to do this in my head. I get negative 3 minus 5 is negative 8. I plug in 0. I get negative 5. I plug in 1. I get, let's see, 3 minus 5 is negative 2. All right, so I'm going to come over here and graph this. Looks like a lot of stuff down in quadrant 4. Negative 1, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. 0, negative 5. 1, 2, 3, 4, 5. And 1, negative 2. If our math is correct, then these should all be lined up in a straight line. All right. Let's do part B, and then we'll kind of stop and look at both of them, I think. Y equals negative 3 halves x. All right, I'm going to pick values of x for x and solve for y. I'm going to pick values, however, that are even, because I know that this says I have to divide by 2. 3 halves is multiplying by 3 and dividing by 2. So I think I'll pick negative 2, 0, and positive 2 this time. Plug in negative 2. A negative times a negative is a positive. The 2's cancel, and I get positive 3. 0 gives me 0. 2, the 2's cancel, and I get negative 3. So this was part A here. Let's squeeze in a part B. I've got negative 2, 1, 2, 1, 2, 3, 0, 0, and 2, negative 3. And luckily enough, they all lie in a straight line, so I feel good about my points. And let's do one more here. Part C is another fraction, y equals 1/3 x plus 1. I'm going to pick values of x that are divisible by 3 to make this easier myself. So I'm going to go negative 3, 0, and positive 3. I can do more points. I can do 6 and 9 and 12 and keep going. All right, a negative 3 cancels a 3. I'm left with negative 1 plus 1. That's 0. 0 I plug in, I get 1. 3 I plug in, the 3's cancel. I'm left with 1 plus 1 is 2. So if I graph this one, negative 3, 1, 2, 3, 0, 0, 1, and then 1, 2, 3, 1, 2. And I'll just go ahead and do D now. Y equals negative 2x minus 3. Quick table. Now it doesn't matter. I'm not dividing, so I'll just go back like negative 1, 0, and 1. Do the math in my head. Negative 1 and negative 2 is positive 2. Minus 3 is negative 1. Plug in 0, I get negative 3. 1, I get negative 5. So on part D, I've got negative 1, negative 1, 0, 1, 2, 3, and then 1, negative 5. All right, graph I'm making table values, check. Use the graph to identify the slope and the y-intercept. All right, so on each of these, I'm going to identify my slope. And for reasons, again, that there is a reason, but it's not worth going into right now, we call the y-intercept b. So m, let's just count them. We're going, it's positive. I go up 1, 2, 3, and over 1. My slope is 3. My y-intercept, where do I cross the y-axis at? 1, 2, 3, 4, 5. I cross it at negative 5. This one, my slope is negative. I'm going down. How far am I going down? I'm going down 1, 2, 3, and over 2. So negative 3 halves. And my y-intercept is right through the origin, so that's 0. My slope on this one is up 1 over 3, positive. It's going up. My y-intercept is at positive 1. My slope is going down. It's negative. Negative 2 over 1, or just negative 2. And then my y-intercept looks like 1, 2, negative 3. Okay, so what I'd like you to do now, if you haven't already noticed it, is make the connection between everything we just did and the equation of the line. All right, you'll notice that on part A, the equation was y equals 3x minus 5. We said the slope was 3 and the y-intercept is negative 5. Notice we have a 3 multiplied by the x, and we have a minus 5 being added or subtracted. On part B, we have a slope that we said was negative 3 halves. Well, there's a negative 3 halves being multiplied by x. And then the y-intercept is 0. I have a plus 0 being added here, and that's the same. 1/3, 1/3. Y-intercept is 1. We have a plus 1. Slope is negative 2, negative 2. Y-intercept is negative 3. We have a minus 3. So what we have here is a very quick and easy way of graphing all lines with recognizing that if they're in the right form, you can just read a great starting point, the y-intercept, and the slope. So all of these graphs I could have graphed by just saying, okay, part A, the y-intercept is -5. So I come down here and I put a dot at -5, and my slope is 3. Up 3 over 1. Up 3 over 1. And I've got my line graphed. So this is what's known as, so I've already done this part, right? Notice the connection between the slope and the y-intercept and the equation. And so what we noticed was the slope of the line is the number multiplied by x, the coefficient of x. And the y-intercept of the line is just the number that's being added to the x term, also known as the constant. Okay, so now what I'd like us to do is we're going to go back up to our warm-up, and I want you to write the equations of the lines that we graphed in those warm-ups. So all we need to know is we need to know what their y-intercepts are and their slope. So m is the slope, and b is our y-intercept. All right, let's flip back to that page. Here we go. Part A. They gave us the slope is 2/3. The y-intercept was -6. And so the answer is, the equation of this line is y equals 2/3 x minus 6. The slope was the number in front of the x, the coefficient, and the y-intercept was the thing being added or subtracted. So on this one, part B, they gave us the slope of -1/4. So I have y equals -1/4 x, and my y-intercept is -1. On part C, my slope is -3. My y-intercept is 0. So this is y equals -3x plus 0. We don't need to write the plus 0 because that means nothing. Part D, my slope is 1/2. My y-intercept is at 2. Y equals 1/2 x plus 2. And E, my slope is -3/8. My y-intercept is 4. So I get y equals -3/8 x plus 4. All right, now we get to our special cases, and these are going to be a little bit weird. We can at least do f exactly the same way. My slope is 0, and my y-intercept is -2. So if I go ahead and write y equals 0x minus 2, that just simplifies down to y equals -2. And let's think about that for just a quick moment. Y equals -2. What do all of these points, or all the points on this line, have in common? Right? All of these points, I don't know what their x values are, but there's one thing for sure that I know, and that is that their y's equal -2. So this is saying find every single point that satisfies y equals -2. In other words, the x doesn't matter. You're going to do every x, and the y values will all be -2. Y equals -2. What do all of these points on this last one, on part G, right? I can't even tell you what the slope is because there is no slope, right? It's undefined. So I cannot write it like I did the others. So this is a special case. But the easy way to do this is just to ask yourself a quick question. What does every point on this line have in common? Right? Every single point, no matter what I've drawn here, they're all at -1 comma something. This is at -1 comma something. This is at -1 comma something. All of these points are at -1 comma something. And so what is consistent? All of the x's equal -1. So this is the only one that doesn't fit into the same model as the other ones. And that's because, number one, it has no y-intercept, right? And it has no slope. So we cannot use those two things to write the equation. we have to just use our wits and figure it out. All right, let's back up to the video copy here. All right, so we did that. Now let's just test our knowledge. Example 4, graph using the slope and the y-intercept. So I look at this first problem, and I'm just going to write it down. I'm going to write down my y-intercept is -1. My slope is 3, and if it helps you, you can call it 3 over 1. So if I graph this, just think about what those two numbers tell us. Slope tells us a direction. A y-intercept is a point. So I need to start this graph somewhere. So I'm always going to start by putting the y-intercept at -1 there. And then my slope is 3, meaning from this known point, I go up 1, 2, 3, and over 1. 1, 2, 3, over 1. I could also go 1, 2, 3 down and negative. And I get this line. Keep in mind, we draw a line because there are infinite number of points here. We're usually plugging in nice, friendly whole numbers, but all these little x values in between, right, they all have y values. And so we use a line to represent them all. My y-intercept on this one is -2, and my slope is 3/2. I'm going to double check. It's a positive 3/2, so my graph should be going up when I'm done. Y-intercept is -2. And I go up 3, 1, 2, 3, and over 2. 1, 2, 3, over 2. And there is the graph of that line. Which brings us to this statement right here. The slope-intercept form of a line is y equals mx plus b, where m represents the slope and b represents the y-intercept. So if you are in this form, then it's easy to graph because you know a starting point, and then you know a direction. All right, that ends our video on section 2.2. If you have questions, make sure you ask them.